This
question
conference will now be recorded.
and I'll respond every question. Okay. Okay, Ramesh. Fine. In yesterday's class, we discussed about the basic LED programs, and today we are going to deal with byte LED. Okay, byte LEDs. So actually, if you observe in the last class, guys, I just took only one single bit, right? We discussed about only one LED, two LEDs like that. But today we are going to deal with the 8 LEDs. It means that we are going to take a total port. Okay, we are going to take a total port. How it works, let me see. Byte LEDs. Okay, so today we are going to take total port, like whatever the port you want to take, port 2, port 3, or port 1. In these three ports, we are going to take total port. Okay, so byte LED means obviously you all are aware of that, 8 LEDs. Fine. First of all, let me design the hardware part. Let me design the hardware part. Then we'll see what are the operations we want to do in the 8 LEDs. Fine. Let you open your Proteus 8 professional. Okay. Go to ISIS. Fine. Where P is the where P is called pick the device, L is called list of the device. We want to pick the device. Click on P. What is the microcontroller? You ought to respond in the chat box now. No other option for you. What's the microcontroller which you are using? Which we are using? Could you please respond in chat box? What I want to type there and what is the device? Please respond in chat box. ATC 8951. Bob. Okay. 8089C51. That's good. Yes. 8089C51. This is our microcontroller. Okay. 8089C51. Double click on this. Okay, and click on that and go to that right side the bottom. Okay, click on OK. And again, I just want to take LEDs. Okay, here I want to choose in this four only. Better to choose in this four only. Okay, blue, green, red, and yellow. In these LEDs, I'm going to choose LED yellow. Right. Double click on that. Close up. Fine. Click on your microcontroller. Place it in the workspace. Don't feel I'm going fast. Fine. So clear. I am going to take this complete port 2. Okay, I'm going to take this complete port 2. Fine. Fine. Hmm. Give the connections for these 8 LEDs. Give the connection. Give the connections. Fine. Fine. And the next step is like we are going to do in common cathode, take the ground and keep it somewhere, connect that. Mm, fine. My hardware part is completed. Let me check whether it is working or not. Yes, that's good. Fine. If you are done with the hardware part, I'll we'll do the operations what these eight LEDs will do. Okay. If you are done with this hardware part, I'll go forward. Respond in chat box. Okay, guys, have we done with this hardware part? Yes. I think you have to do parallel along with me. Just a minute, sir. Okay, I will wait. No worries. Okay, Trisha. Okay, someone mentioned there in the above. You belongs to MIC. Okay, MIC College of. Kiran Naipinda, have you done with this hardware part? So guys, better to like give space between above 4 LEDs and below 4 LEDs because the connections will get కొంచెం ఇబ్బంది చేస్తుంది. So you can give the connections. I mean that you can place this LEDs a little bit far. Okay, fine. So guys, actually, you know, we have taken complete port 2. We are using this total 8 pins. Actually, you can play with this. See, for example, if I want to make this first LED and this last LED, it means that if I want to make on, okay, if we want to on this first LED and last LED, we can do that. As well as if you want to make all these above 4 LEDs on, we can off this above below 4 LEDs off. Okay, even LEDs on or all odd LEDs off, or odd LEDs on, even LEDs off. It's your wish. You can play with this. Okay, so the major point in this topic is like you want to know about the conversion to hexadecimal, binary to hexadecimal. Okay, everybody have to aware of this, how to convert from binary to hexadecimal. Okay, we are going to in the code we are going to directly we are going to give the hexa value, hexadecimal value. Okay, in this way the microcontroller will understand what we want to explain, what we want to do. Clear? So actually there are so many possibilities are there, so many probabilities are there. Like as I said that if you want to make this LED, fourth LED on, fifth LED off, if you want to make only two LEDs off on, remaining all LEDs off. Okay, that's what I'm saying, that you can play with this actually. Whatever the LED you want to make on, you can make it on. Whatever the LED, if you want to make remaining all LEDs off, you can do that. Okay, so first of all, I'm going to take only 6 conditions because no time is there for us. Okay, fine. uh, I want to make this first 4 LEDs on. Okay, this is my first probability. Okay, and second one is that first last 4 I will make on, I'm remaining that I'll make these 4 off. Okay, when I make these 4 on, I'll make these 4 off. When I make these 4 on, I'll make these 4 off. Okay, in the same way I'm going to on the even LEDs, I'm going to on the odd LEDs, and the remaining 2 cases are like uh, even LEDs or odd LEDs, first 4 last 4. I mean the last one is like I want to make all LEDs on, all LEDs on. Fine. uh Let me go ahead with this notepad where they'll get a clear idea. Okay, so guys, this is our hardware part. It means that I'm going to take the pins from backside, 2.7, 2.6, 2.5, 2.3, like this. Okay, let me take here 2.2, 2.7, 2.6, 2.6, 2.5, 2.4, 2.3, 2.2, 2.1, 2.0. So if you observe 8 pins, 1, 2, 3, 4, 5, 6, 7, 8, clear. Fine. So I want to make all LEDs on. I want to make all LEDs on. Guys, you are getting my point, right? So again, I'm telling you that it's your wish to do anything. That's what I'm saying you, that you can play with this. Okay, if you are aware of this, converting from binary to hexadecimal. Right? I am going to make all LEDs on. So what is the hexadecimal value for this? Guys, you have to respond that. Okay, what is the hexadecimal value? Please respond in chat box. What is the hexadecimal value for this binary form? FF, good. 0x. For hexa, you will get 0x, which represents hexa. 0x in the sense like which comes under the hexadecimal value. Okay, so when you're writing the hexadecimal value, you have to place 0x there. Okay, that is a symbol of hexa, and 0x FF. Guys, have you understand how it came? If you do not understand, I'll tell you. Have you understand that how it came like 0x FF? 0x belongs to hexa, FF in a sense like all these 8 are ones, so that you'll get FF. Have you got my, have you got how we got that FF? Yes. Okay, so in the form of 841 logic, I will simply write it here because of understanding. 8 4 2 1, again 8 4 2 1. If you add all these numbers, okay, you have to separate 4 bits, 4 bits. Okay, if you add 8 4 2 1, you'll get F. It means that 8 4 12 13 14 15. Okay, 15 in a sense like F. Yes, this is for all LEDs on. Fine. I want to make all LEDs off. This is my second possibility and second probability. I want to make all LEDs off. What is the hexadecimal value for this? What is the hexadecimal value for this? Make it fast. What is the hexadecimal value for this? Please respond in chat box. 00. Yes. All LEDs are fine. What is happening? Charging. Yes. Fine. Third possibility I'm taking is, let me make the first 4 LEDs on. First 4 LEDs on. Okay, I want to make these 4 LEDs on. Fine. It means that pin number 0, 1, 2 and 3. Okay, only these pins should be high. Remaining these pins 4, 5, 6, 7 should be off. Fine. So it means that these pins should be low, 4, and these pins should be high. Fine. What is the hexadecimal value for this? What is the hexadecimal value for this? 0x0f. That's good. 4 LEDs. Only first 4. First 4 on. Okay. And fourth probability I'm going to take is like, let me take the even LEDs. Okay. Even LEDs. 2 is an even, 4 is an even, 6 is an even, and 8 is an even. I'm going to make these even LEDs on. Guys, you can do some other LEDs on. Okay, you can do, actually that's what I said, you can play with this. Okay, by using this hexadecimal value. Fine. I'm not saying you that do only this only. Okay, do as your wish. Fine. So I want to make even LEDs on. Even LEDs in the sense like 2 is an even, 4 is an even, 6 is an even, and 8 is an even. It means that 2.2, 2.4, 2.6 until now, 2.8. So 2.1, guys are getting 2.1, 2.3, 2.5 and 2.7. I want to make these LEDs on. Fine. So 2.6. Fine. 3, 5, 7. Yes. So I want to make these LEDs. Yes. 0. As am I doing correct? 2.7. No. Turn respond as chat box. No. Guys, please respond if I'm doing 2.7 should be on. Okay. 2.7 should be on. 2.7 should be on. off, on, off, on, off, on, and off. Fine. What is the hexadecimal value for this? Is it clear? Is it okay? 2.7 should be on. 2.5 should be on. 2.1 should be on. 2.3 should be on. Yes. 2.3 should be on. Yes. What is the hexadecimal value? 0x55. Is it correct? Zero x 55842. 1 second, guys. 1 second. Whether what you said is correct or not. 0x55810. 0x AA. Yes. 8 plus 2 is equal to 10, right? So 10 is equal to A. 0x AA. I'm not checking what you said. I'm going with that. Even LEDs. Fine. So for let me make these 4 LEDs off, or we'll go with odd LEDs. No need of, let me go with uh, these 4 off. Okay, we'll make these 4 off, which means that 2.4 to 2.7 we'll make 2.4 to 2.7. It means that uh, these 4 LEDs on, these 4 LEDs off. It means that below 4 LEDs we are making it off. We are offing that. So this is our binary format. What is the hexa code for this? What is the hexadecimal value for this? 0x F0. Yes. Last 4. You can do some other. Okay. Last one, I'm going to make odd LEDs. Okay. I'm going to make on only odd LEDs. Odd LEDs in the sense like opposite to this. Opposite of even LEDs, right? 1, 0, 1, and 0. Is it fine? For this 1, for this 0, for this 1. Yes. What is the hexadecimal value for this? 01010101. Now you said correct. 0x55. Odd LEDs on. Don't sleep, guys. Okay. After completion of your lunch, the class is there. So please don't sleep. Fine. Okay. Now we are going to write a code. Okay. So these are the operations what we want to do in that byte LEDs. Fine. What is the header file? What is the header file for this? Please respond. What is the header file? These are the operations what we want to do. It's your wish. If you want to do any operation, you can go ahead. Okay, it's only my comfort. I'm taking it. Reg 51.h. Yes. 51.h. Okay. This is the header file. What is the second step? What is the second step? I said in the last class that if you are going to use total port 2, you have hardware declaration, correct? So we are going to take total port 2, so that I am just defining it in the hardware part as port 2. We define hardware part port 2 in the second step. Clear? Next, function declaration, void delay, void main. Okay, so these are the steps we discussed. Function declaration, correct? Next, main function. Okay, we are going to open this. And why we are going to use this while loop? It's an infinite loop. which is used to execute for infinite times. Clear? Fine. So now the real task will begin. Fine. While of one opened, so port 2 is equal to so what is our first task, first condition? 0xff, right? Port 2 is equal to 0xff. Clear? Here I don't want to mention that because all LEDs on. Okay, now you have to give some delay. Very simple programming, guys. Port 2, second possibility, this is a condition of 0x00, 0x00, and again you have to give some delay for this also. Clear? Again port 2 is equal to, what is the third condition? 0x 0f, 0x 0f, again you have to give some delay. Guys, are you following? Are you getting my point, what I'm saying? That, or like I want to increase the voice more, are you getting? Could you please respond? Is it going good? Port 2 is equal to 0x, yes, thank you Kiran, 0x 0f, 0x a, yes, thank you 0x a, and for this also you have to give some delay. For every operation you have to give some delay. 0x a. Next port 2 is equal to 0x f0, 0x f0, right? For this you have to give some delay. Last condition is that 0x55, port I, port 2 is equal to 0x55. Done. This is the delay. And we know that after writing all these things, you have to make, you ought to close this while loop as well as main loop, main function, and last one, mandatory function. This is what function definition, right? This is called function definition. Open this, int I comma j, mandatory, that's what we discussed in the last class. For loop for I is equal to 0, I less than 100, I plus plus increment, as well as for j is equal to 0, j less than 1000, j plus plus. Completed. Clear? These are the conditions. What for these conditions, this is a code. Any hasn't this origin 51.h, any mistakes as defined port 2. Clear? Clear. Yes, this is the code. When open your key, open the key, go to this project, new microvision project. In Keel, I'm going to take it as a new folder called byte LEDs. Byte LEDs. In this byte LEDs, I'm going to save it as byte LEDs. Okay, I'm going to save it as byte LEDs. Fine. This is where you want to select our hero 8089C51. 8089C51. This is our microcontroller. Select it. Click on it. Okay. It's your wish. If you want to click yes, it's okay. If better to click no. Okay. And go to file, take new file and save it. Save it as byte leds dot c. Extension of dot c is mandatory because we are writing a code in embedded C. Clear? Save it as and add the existing file to group, source group. Okay, byte leds, I'm going to add this and close. Fine. Guys, is it okay up to here? And again, I'm going to this is our code, has includes org51.h, control C, control V. Fine. Build this. Okay, if you build this, you'll get 0 errors as well as 0 warnings. And go to this target one, right click on this options for target one. Go to the target one, options for target one, click on this, change the clock frequency. 11.0592 is the clock frequency. Output, go to the output, create hexa file. Fine. Okay, you must and should go ahead with this rebuild. Okay, creating hexa file. Okay, the hexa file is created. We want to dump this hexa file into this microcontroller. Fine, double click on this microcontroller, change this clock frequency to 11.0592, and program file. In this program file you have to select the path. Go to the desktop and open your key. In byte leds there is a hexa file. Fine, byte leds dot hex. Okay, let me check whether it works or not. Yeah, all on, 4 on, yes, off, 4 on, 4 off. Okay, one second, let me increase the delay. 4 on, it takes time now. 4 off, again 4 on. Yeah, it's working, right? Even LED is on, even LED is on. Now 4 off, now odd LEDs. So whatever the conditions we have taken, we completed that. Fine. Yes, guys, give me 1 minute. I'll take the screenshots of this. So meanwhile, if you are not done with this, you can complete that. You can complete that. Okay. So guys, fine. Yeah. I'll do that. Control C. So this is a code. Guys, is it clear for you? Where is this notepad? Yes, here it is. Is it clear for you guys? అర్థమైందా? Okay, fine. Now let me pick at least so I pasted the code. Is so Vikas, can I give you the presenter? Can you show what you done? Okay. Are you logged in lab or like in phone? So guys, is there anybody to take the presenter? Is there anybody to take the presenter? So I have done same. No worries. If you have done the same, no worries. You did not get it. Why? Kiran ఎందుకు రాలేదు? So Kiran, okay, fine. Can I give the presenter? Can you show? Can you share your screen? I'll see the error. What is the error? Yes. I hope you log in laptop or a desktop. I'm going to give you the presenter for you. What's your name? See. Where are you? See this. Kiran, share your screen. Let me check what is the error there. Mm. Can you unmute your mic? ఒకసారి మైక్ ఆన్ చేయి చెప్తా. ప్రాబ్లం ఏంటి? వాట్స్ ద ఎర్రర్? కిరణ్, వాట్స్ ద ఎర్రర్? నెక్స్ట్ ఆపరేషన్స్ రన్ అవ్వట్లేదా? నెక్స్ట్ ఆపరేషన్స్ ఒకసారి కోడ్ ఓపెన్ చేయనా? ఒకసారి కోడ్ ఓపెన్ చేయనా?
కోడ్ సార్.
Code to delay main value. One second. F1 or 2000 0. ఒకసారి ప్రోటీస్ ఓపెన్ చేయి. ఒక్క నిమిషం. హెక్సాఫైల్ క్రియేట్ చేసావా? పాత్ చూస్ చేసుకో. డబుల్ క్లిక్ చేయి. మైక్రో కంట్రోలర్ మీద డబుల్ క్లిక్ చేయి.
ఓకే సార్.
వైట్ led.hex క్లిక్ ఆన్ ఓకే. కాదు ఇక్కడ మెగా హెడ్ చేయది
సార్.
కాదు ఒక పని చేయి. కానీ క్లిక్ చేయి యాక్చువల్గా నేను అందుకే చెప్తాను అక్కడ మెగా హెడ్స్ ని డిస్టర్బ్ చేయకుండా ఉంటే బాగుంటుందని. ఏం చేస్తావు మళ్ళీ అంటే ఒకసారి మెగా హెడ్స్ టైప్ చేయాలన్నా MHZ అని క్యాపిటల్ MHZ క్యాపిటల్ HZ యా ఓకే. ఇప్పుడు రన్ చేయి ఒకసారి. ఓకేనా?
స్లోగా వస్తుంది సార్ అది.
అప్పుడు డిలే
Delay change
తగ్గించాను. డిలే తగ్గించేసి.
ఓకే సార్, వస్తుంది సార్, వస్తుంది సార్.
ఓకే ఓకే. ఓకే
ఓకే సార్.
యా guys, everybody done with this? Can I move forward? Can I go forward? Yes, Aditya. Nikita, have you done this? Yes. Yes. Thank you. 1 second. Next task is like button interfacing with 8051. Button interfacing with 8051. So in this button interfacing with 8051, button interfacing with the microcontroller, there are two types, two methods are there. There are two methods. First one is, remember, pull down method. First one is, or I can call it as a pull down method. Second one is obviously pull up method, right? Pull up method. How this pull down will looks like? Any guess? Third. Okay, so I'll tell you, I'll draw it for you. Okay, it gives more clarity for you. In this button interfacing with in this button concept, there are two methods are there, guys. First one is pull down method, where like the resistor is connected to ground in this pull down method. Remember this. Okay, the resistor, one end of this button is connected to resistor, a resistor is connected to ground, which is called pull down method. So pull up method is, for this resistor you have to connect the power supply. Okay, these are the two methods are there. I will tell you and I'm going to draw for you. It will be very clear for you. Okay, so in this pull down method, remember that the resistor should grounded. In pull up method, resistor should connected for a power supply. That's it. Fine. So let me take paint. So this is called button. Fine. So one end of this button is connected to resistor and resistance should ground it. Okay, here you have to connect at this point. It means that at this point you need to connect our pin. Our microcontroller pin will be connected at this point. Fine. And other end of this button will connect it to power supply. Guys, could you please wait for 1 minute? Only 1 minute. So guys, this is called pull down method. Fine. Obviously, two terminals will be there, two ends will be there for a button. One end will connect it to directly for 5 volts power supply. Other end is connected to a resistor, and the resistor should ground it. Okay, this is called pull down method. Obviously, what is called pull up method? Same push pull button. This is the button. Okay. The resistor should connect it for power supply. Here in this pull down method, the resistor is connected to ground, but here in this pull up method, okay, the resistor is connected for power supply. Fine. Obviously, the second end, this is the symbol of button. Okay. Other end is directly connected to ground. Here we are going to connect our microcontroller pin. So these are the two methods, two types are there in this button concept. Fine. We will check both these two, how it works. I pull up. Fine. Guys, if my diagrams are not good, ignore this. Fine. But try to focus like how this pull downs looks like. So remember this, guys, while we are designing this in the hardware part. Okay, next we are going to do this. Okay, and what are the components we required? Obviously, we need the required resistor is needed, button is needed, or microcontroller is needed, and we are going to do all these things by using LED. Okay, by using the LED, we are going to do all these things. Remember, what are the components required? Resistor is needed. Okay, button is needed, and microcontroller is needed. Clear? And power supply and ground should be there in the terminal mode. Fine. We'll see how it works and what is the code, like how to control an LED by using these two methods. Fine. Go to this Proteus hardware part. Go to this component mode. Let me delete this first of all. Fine. Okay. RES. If you type RES, you'll get a resistor. Okay, directly. Type RES, you'll get a resistor. Right click on this, double click on this, and go to button. Type button. You'll get active SPST button. Okay, push button. Fine. Select this. These are the required components what we need, right? For this, I'm going to take again port 2 only because it's my comfort. Okay. First of all, let me place button. Fine. Let me take this button. Guys, which method is this? Which method is this? LED. Okay, take this LED. Anode is connected to power supply, which means that pin. And guys, which method is this? Pull up. That's good. That's good. That's good. Pull up method. Fine. Yes. My God. 5 మంది వెళ్ళిపోయారు అప్పుడే. Fine. ఒక్కరున్నా చెప్పక తప్పదు. Fine. Okay, no worries. Guys, remember that. Let's pay attention here. Okay. Here, let me run this first of all. Let me run this. Guys, if you focus on this button, there is a power supply, right? Obviously, red indicates that there is a 5 volt DC power supply is passing through it. Okay, here resistance acts which opposes the flow of current. Okay, resistor acts as an opposing of current or a power supply. If you observe in this at a button, okay, here there is a power supply, right? Because button is directly connected to microcontroller. If you clearly observe, if I press this button, what is the logic applied there? Guys, please focus on this. ఇప్పుడు నేను బటన్ ప్రెస్ చేయకుండా ఉంటే అక్కడ లాజిక్ 1 అప్లై అవుతుంది. ఇఫ్ యూ క్లియర్లీ అబ్జర్వ్, డోంట్ ఫోకస్ ఆన్ దిస్ ఎల్ఈడి. హియర్ నేను బటన్ ప్రెస్ చేయకుండా ఉంటే దెర్ ఈజ్ ఎ లాజిక్ 1 అప్లైడ్ డైరెక్ట్లీ. అవునా? సో ఇక్కడ నేను మన థీమ్ ఏంటి? బటన్ ప్రెస్ చేస్తే ఎల్ఈడి ఆన్ అవ్వాలి. దిస్ ఈజ్ అవర్ టార్గెట్. బటన్ ప్రెస్ చేస్తే ఎల్ఈడి ఆన్ అవ్వాలి. నేను ఇక్కడ బటన్ ప్రెస్ చేస్తే ఏం అప్లై అవుతుంది? లాజిక్ 0 అప్లై అవుతుంది. విచ్ మీన్స్ దట్ if I use logic 0, then obviously the LED becomes on. Okay, అప్పుడు మనం ఏం చేయాలి? ఇక్కడ కోడ్ లో బటన్ కంపేర్ చేయాలి. బటన్ 0 అయితే, అర్థం చేసుకోండి, బటన్ 0 అయితే ఎల్ఈడి ఆన్ అవ్వాలి. దిస్ ఈస్ ద థింగ్ విచ్ వీ హ్యావ్ టు రైట్ ఇన్ అ కోడ్. ఇక్కడ మనం 0 ఎందుకు రాయాలి? వై వీ హ్యావ్ టు టేక్ లాజిక్ 0 దేర్? సో బికాస్ ఇఫ్ యూ ప్రెస్ దిస్ బటన్, ద లాజిక్ 0 is applying there. In the place of button, లాజిక్ 0, మనం బటన్ ప్రెస్ చేస్తే ఎల్ఈడి ఆన్ అవ్వాలి. బటన్ ప్రెస్ చేస్తే లాజిక్ 0 అవుతుంది. లాజిక్ 0 అయితే ఎల్ఈడి ఆన్ అవ్వాలి. దిస్ ఇస్ అవర్ టార్గెట్. ఇదే కోడ్ లో రాయాలి. క్లియర్? అర్థమైంది? అర్థం కాకపోతే ఒకసారి అడగండి, నేను రెస్పాండ్. అర్థం కాకపోతే అడగండి, నేను రెస్పాండ్ అవుతాను. జాగ్రత్తగా వినండి. ఇక్కడ నేను జస్ట్ కోడ్ ఏం రాయలేదు. ఐ హావ్ నాట్ రిటన్ ఎనీ కోడ్, బట్ ఒకసారి రన్ చేసి చూస్తే దేర్ ఇస్ అ పవర్ సప్లై టు దిస్ బటన్. లాజిక్ 1 అప్లై అయింది. వితౌట్ రైట్ ఎనీ కోడ్, దేర్ ఈస్ ఎ లాజిక్ 1. మన కాన్సెప్ట్ ఏంటి? బటన్ ప్రెస్ చేస్తే ఎల్ఈడి ఆన్ అవ్వాలి. బై యూజింగ్ ద బటన్ వీ వాంట్ టు మేక్ దిస్ ఎల్ఈడి ఆన్. కానీ ఎల్ఈడి ఆన్ అవ్వాలంటే బటన్ ప్రెస్ చేయాలి. బటన్ ప్రెస్ చేస్తే లాజిక్ 0 అప్లై అయింది. సో కోడ్ లో ఏం రాయాలి? లాజిక్ 0 అప్లై అయితే, అంటే బటన్ ఈజ్ ఈక్వల్ టు 0 అయితే, విచ్ మీన్స్ దట్ కంపేర్ చేయాలి. బటన్ 0 అయితే ఎల్ఈడి ఆన్ అవ్వాలి. ఇది వీఆర్ గోయింగ్ టు రైట్ ఇన్ ద కోడ్. అర్థమైందా? ఐ హోప్ ఇట్స్ క్లియర్ ఫర్ యూ. అని పెద్ద ప్రాబ్లం ఏం కాదు. లాజిక్ 0 ఆబ్వియస్లీ మనం బటన్ ప్రెస్ చేయకుండా లాజిక్ 1 అప్లై అయింది. బటన్ ప్రెస్ చేస్తే లాజిక్ 0 అప్లై అవుతుంది. ఓకే, రెడ్ కలర్ నుంచి బ్లూ కలర్ వస్తుంది చూడండి. రెడ్ ఈజ్ ఏ పవర్ సప్లై, బ్లూ ఈజ్ లాజిక్ 0. అంటే నేను ఇప్పుడు బటన్ ప్రెస్ చేస్తే లాజిక్ 0 అయితే ఎల్ఈడి ఆన్ అవ్వాలి. రైట్, ఇట్ విల్ బి క్లియర్ ఫర్ యూ వైల్ రైటింగ్ ఎ కోడ్. ఓకే, hash includes reg51.h. this is our header file. Next, spit button is equal to బటన్ దీన్ని కనెక్ట్ చేసాం, పోర్ట్ 1 పిన్ 2 కనెక్ట్ చేసాం అంతేనా. పోర్ట్ 1 పిన్ 2 కనెక్ట్ చేసాం. క్లియర్? నెక్స్ట్ ఎస్బిట్ ఎల్ఈడి ఈజ్ ఈక్వల్ టు, ఎల్ఈడి దేన్ని కనెక్ట్ చేసాం, పోర్ట్ 2 పిన్ 2 అంతేగా. పోర్ట్ 2 ఎల్ఈడి is connected to పోర్ట్ 2 పిన్ నెంబర్ 2. ఫైన్. నెక్స్ట్ void main. ఓకే, కండిషన్ ఏంటి, ఇఫ్ బటన్ is equal to 0 అయితే, దిస్ ఈజ్ అవర్ కండిషన్ మెయిన్. ఇఫ్ బటన్ is equal to 0 అయితే ఎల్ఈడి అనేది ఆన్ అవ్వాలి. ఎల్ఈడి అనేది ఆన్ అవ్వాలి. క్లియర్? ఎల్స్ ఎల్ఈడి అనేది ఆఫ్ అవ్వాలి. క్లియర్గా అర్థమైంది అనుకుంటున్నాను. దిస్ ఈజ్ అవర్ కోడ్. బటన్ 0 అయితే ఎల్ఈడి ఆన్ అవ్వాలి, లేదంటే బటన్ ఆఫ్ అవ్వాలి. దిస్ ఇస్ అవర్ కండిషన్ విచ్ we simply written in the code. Fine. Go to this key. Again go to the new microvision project. Come to key, take the folder. Guys, you can save in only single folder only. I'm just taking you for your convenience. And that me understanding కోసం I'm taking a new folder. Okay, button button. Okay, in this button I'm going to save it as button. Save. Take our microcontroller 8089C51. This is our microcontroller. Select it, click on OK. No. Okay, and save this. Save this. Not in byte, in button. Path plays a key role. Button dot C. Extension of C is mandatory. Save it as add existing file. Button add close. Guys, I'm a little bit fast in this point. Okay, whatever the code we written there, just paste it. Control C, Control V. Fine. Build this. Yeah, we got 0 errors and 0 warnings. Fine. Go to this target one, right click on this, options for target one, change the clock frequency 11.0592. Go to this output, create hexa file. Okay, rebuild this. Fine. 0 errors and 0 warnings. The hexa file is created. And go to the Proteus, double click on this, Not this byte desktop kale in this button dot hex. Fine. Okay. Yes. Guys, ఇప్పుడు నేను ప్రెస్ చేస్తే if you observe very clearly that see లాజిక్ ఏమి ఇస్తున్నాను ఇప్పుడు లాజిక్ 0 ఇస్తున్నాను అంటే if I press this button I'm applying logic 0 obviously there is an LED on. అర్థమైందా? Is it clear for you? సింపుల్ నార్మల్ పాయింట్ యాక్చువల్గా వితౌట్ నేను ఏమి అసలు బటన్ మనం జస్ట్ కోడ్ రన్ అయితే ఇక్కడ లాజిక్ 1 అప్లై అవుతుంది, మనం బటన్ ప్రెస్ చేస్తే లాజిక్ 0 అప్లై అవుతుంది కాబట్టి సో ఇప్పుడు నేను లాజిక్ 0 అప్లై అయ్యేటట్టుగా నేను కోడ్ రాయాలి అంటే బటన్ ఈజ్ ఈక్వల్ టు 0 అయినప్పుడు ఆబ్వియస్లీ ఎల్ఈడి ఆన్ అవుతుంది. ఎప్పుడు బటన్ 0 అవుతుంది, నేను బటన్ ప్రెస్ చేస్తే ఎల్ఈడి ఆన్ అవుతుంది. అర్థం కాకపోతే అడగండి, ఐ విల్ టెల్ యూ. 1 second, let me take the screenshots of this. I don't know what's the reason. Fine. Guys, have you got what I said? అర్థమైందా? Could you please respond in chat box? Yes. Okay. Guys, remember this. I just want to mention one point here that it's in a practical case. Remember, it's in a practical case. If you want to use the button in a practically, you need to do all these things, like you have to take the power supply, resistor, button, LED. Okay, so let me do one thing at this point, that no need after doing this I'll do that. Okay, fine. So guys, remember here we have taken common cathode type. Remember, here we have taken common cathode type. It means that cathode is grounded, right? So let me change this to anode. What happens? So if you change this to anode, it means that here cathode is grounded. In common anode, cathode is connected to power supply, anode is connected to in that cathode is connected to pin, anode is connected to power supply. Okay, I'm just rotating this. Okay, up to now we saw common cathode type, which means that cathode is connected to ground. If you connect this cathode to power supply, if you connect this cathode to microcontroller, what happens? What are the conditions? Apply for LED. Okay, I'll tell you. Fine. Meanwhile, let me stop this and let me rotate this. Delete wire. Yes, cathode is connected to power supply. Fine. Anode is cathode is connected to pin, anode is connected to power supply. Fine. What is the logic? So what are the conditions apply for LED? సో ఇప్పటిదాకా మనం ఏం చేసాం, కామన్ క్యాథోడ్ లో 1 ఇస్తే ఆన్ అవుతుంది, 0 ఇస్తే ఆఫ్ అవుతుంది. దిస్ ఈస్ ద థింగ్ విచ్ వి డిస్కస్డ్ అప్ టు నౌ. ఫైన్. ఇన్ కామన్ యానోడ్ లో ఏమవుతుందంటే 0 ఇస్తే ఎల్ఈడి ఆన్ అవుతుంది, 1 ఇస్తే ఎల్ఈడి ఆఫ్ అవుతుంది. రివర్స్, ద కండిషన్ గెట్స్ రివర్స్, రైట్? ఫైన్. కామన్ యానోడ్ లో లాజిక్ 0 ఇస్తే ఎల్ఈడి ఆన్, లాజిక్ 0 ఇస్తే ఎల్ఈడి ఆన్, లాజిక్ 1 ఇస్తే ఎల్ఈడి ఆఫ్. ద కండిషన్స్ గెట్ రివర్స్ in common anode, remember. Okay, common anode, anode is connected to power supply. In common cathode, cathode is connected to ground. Remember this. Logic 1 ఇస్తే ఎల్ఈడి అనేది ఆఫ్ అవుతుంది. Okay, so these are the conditions applied for LED. Fine. For common anode, guys are getting bored. Why? I don't know, so many are leaving the class. Okay, logic 1 అప్లై అయితే ఎల్ఈడి అనేది ఆన్ అవుతుంది. ఎల్ఈడి ఆన్. లాజిక్ 0 అప్లై అయితే ఎల్ఈడి అనేది ఆఫ్ అవుతుంది. సో అప్ నో హియర్ కామన్ cathode. ఓకే, అప్ టు నౌ వి సా దిస్, ఇదే చూసాం. 1 ఇస్తే ఎల్ఈడి ఆన్ అవుతుంది, 0 ఇస్తే ఎల్ఈడి ఆఫ్ అవుతుంది. ఇన్ కామన్ క్యాథోడ్ లో 0 ఇస్తేనే ఎల్ఈడి ఆన్ అవుతుంది, 1 ఇస్తే ఎల్ఈడి ఆఫ్ అవుతుంది. రిమెంబర్ దిస్. ఇప్పుడు నేను చేంజ్ చేస్తాను, బికాస్ ఐ హ్యావ్ టేకెన్ కామన్ యానోడ్. ఎందుకంటే యానోడ్ ఇస్ కనెక్టెడ్ టు power supply. Build this, rebuild this. Excel file is created in Proteus. Run here. చూడండి. Okay, cathode is connected to microcontroller to a pin, anode is connected to power supply. The conditions will get reverse. This is the thing which I said here. Okay, for common anode, if you given logic 0, LED becomes on. If you give logic 1, LED becomes off. Fine. Yes. Guys, give me a second. I want to close the class, or like I want to continue the class. Let me ask. Yeah, guys, here I'm going to stop the